Today, we are going to learn how to configure the default routes configuration. Networks allow people to communicate, collaborate in many ways, like sharing information, competing in interactive games, accessing web pages and IP phones and so on. As part of data communication, network devices are responsible for transmitting data packets between network devices. When devices are attached to a LAN network, the Layer 2 device, the switch, is responsible for delivering Ethernet frames between devices. But, sometimes, the destination of the IP packet may be a web server in another country. In other words, the Ethernet frame must be sent to a router, if they are attached to different networks, or when the source IP and destination IP addresses are on various networks. The router is responsible for connectivity between networks and allows it to route network traffic between networks regardless of the user's physical connection. When a packet arrives on a router interface, the router uses its routing table to determine the next hop and how to reach the destination network. As part of the routing process, a router compares each packet's destination IP address to the router's routing table. If the address does not match any routes, the router discards the packet and makes no attempt to recover from the loss. So, to reach remote networks, it is essential that routing be implemented. More directly, to forward a packet to remote networks, the router should learn about a remote network, which can be achieved in two ways: manually and dynamically. Manually is when remote networks are manually entered into the routing table using static routes. With a dynamic approach, remote routes are automatically learned using dynamic routing protocols such as RIP, OSPF, IGRP, and so on. Static routes are routes that match specific packets. But, what happens if the remote network route for the incoming packet does not exist in the routing table? When a packet arrives on an interface of a router, the router reads the destination network address of the incoming packet and finds that network address in the routing table. If the routing table contains an entry for the destination network, the router forwards the incoming packet from the interface that is written next to the destination network in the entry. However, if the routing table does not contain an entry for the destination address, the router drops the incoming packet. This is the concept behind default routes. A default route gives a route to a router to forward all incoming packets whose destination network addresses are not available in the routing table. A default route is a special type of static route that is considered to match all destination IP addresses. With a default route, when a packet's destination IP address does not match any other routes, the router uses the default route for forwarding the packet. It is configured manually to reach network and must be reconfigured anytime the network topology changes. Basically, it is required for two conditions. First, when no other routes in the routing table match the packet destination IP address. In other words, when a more specific match does not exist. Second, when a router has only one other router to which it is connected. In this situation, the router is known as a stub router. A default static route is simply a static route except that the destination address is 0.0.0.0 and the subnet mask is 0.0.0.0. It is one that matches all packets, and is used by the router if packet does not match any other, more specific route in the routing table. Generally, a default route creates a gateway of last resort. What is gateway of last resort? It is the route used by the router when no other known route exists to forward the packet to remote networks. Therefore, any packet whose destination address is not listed in the routing table is forwarded to the default route. With these points in mind, this video focuses on how to configure IP4 default routes to enable remote network connectivity in enterprise campus networks. In this lab, we will configure default routes using the next hop address. So, let's start with creating a network topology and cabling. But, here, I'm going to cable the routers using the serial interface. Because the MAC address does not exist on the serial interface, if it is, the routers may not refer to the address resolution protocol cache, but, instead, The router consults its routing table to reach the remote network. Now, once you select the serial DCE cable, and try to connect the routers, unfortunately, you cannot do the cabling, because there is no serial interface card. For this reason, let me add it by hand. Now it's time to identify IP4 addressing table. The next step is to perform basic router configuration. To do that, enter global configuration mode, and run basic global configuration commands, such as hostname, no IP domain lookup, enable secret, line console, banner and so on. And repeat the same steps on routers 2 and 3. Next, configure and activate the router interfaces using global configuration commands. Additionally, interpret debug output using privileged commands. The main purpose of debug IP routing here is to debug when new routes are added, modified, and deleted from the routing table. This port may require additional configuration parameters. For example, the serial interface connecting to the end of a serial cable marked DCE must be configured with a clock rate command. You see now, all interfaces are activated. Next, configure IP addressing on the host PCs. For example, configure the host PC0 with an IP address of 192.168.10.424 and a default gateway of 192.168.10.1. Now, test and verify your configurations. Test connectivity by pinging from each host to the default gateway configured for that host. For example, from the host PC0, is it possible to ping the default gateway? If your answer is no, please verify and examine router's interfaces. And, test connectivity between directly connected routers. For example, from the router R0, is it possible to ping R1 at 172.16.1.2? Additionally, check connectivity between devices that are not directly connected. For example, from the host PC0, is it possible to ping the host PC1? This ping should fail, because there is no valid route updated on R1 routing table to reach a remote network 192.168.20.0. Well, before starting our configurations, we need to test the status of the router interface and the routing table. A newly deployed router, with a configured direct connected interface, creates two routing table entries that are direct connected routes and a local route. After then, it represents directly connected routing table entries, in three fields. Well, the first field is entry codes, which identify how the network was learned by the router. For example, a directed connected route is coded with C, while a local route is L. The second field identifies the destination network and how it is connected, and the third and final identifies the interface on the router connected to the destination network. So, as you can see from this test, all the routing tables are updated with direct connected routes. There is no entry in the routing table to reach the remote network. To configure default routes, first, we need to identify a direct connected and remote network of each router. So, let's configure the default route for every our1 remote network, which creates the gateway of last resort for these networks. So that our devices in different networks can talk to each other, let us configure the default route using next hop IP address. For example, configure router R1 with the default route, using the serial 0/0/0 interface of R2 as the next hop interface. And perform the respective configurations on R2 and R3. Now verify and examine a default route configurations, using show IP route. Note that, if you notice the routes coded with S*, then that means that the route is a default route. For example, with this configuration shown in the example, any packets not matching more specific route entries are forwarded to 172.16.1.2. In addition, the asterisk indicates that this static route is a candidate default route, which is why it is selected as the gateway of last resort. A default route configuration creates a gateway of last resort. A /0 mask in this route entry indicates that none of the bits are required to match. The default static route matches all packets for which a more specific match does not exist. Finally, check end-to-end connectivity between the hosts connected to different networks using the ping command. For example, ping PC1 from PC0. This ping should be successful this time, because the R1 router can return the packet using the default route. Thanks for watching. If this is your first time viewing this channel, please subscribe and support the channel.